Hey everyone, I just wanted to go over your day 16 AMI work with you. We actually have four problems. We have problem A, which has two, and then we have problem B, which also has two. This is on the top of page 9 of your days 11 through 20, and I'm just looking at it on the Springdale website right now. So let's get right into it. Problem A says a piece of rope is 5 and 75 meters in length. If it is cut into 20 equal pieces, how long will each piece be? This is your question that you're going to be answering. How long will each piece be? So we know how many pieces there are. We know how long the total length of the rope is. So I created a similar problem that you can use to solve. And so we're going to say for our example problem that it is 10.5 meters long. And we're also going to continue, just like this one says 20 equal pieces, we want to cut this one into 20 equal pieces as well. Since we want to do that, we want to know how long is each piece, just like your problem here. How long is each piece? Whenever I was thinking about this, I wanted to kind of show you a rope, and I was thinking if I cut this up, and if I was doing it physically like right in front of me, and I had a piece of rope and some scissors or a knife, and I was cutting this up, I was thinking, would I need to add, subtract, multiply, or divide? And to me, I'm thinking I need to take away from the rope because I need to cut pieces off. So that has to either do with subtraction or division. And I thought, which one makes more sense? Well, if I want to make them all equal pieces, then I probably should divide because dividing will give me all equal pieces. It will tell me how many times how many times can I get something out of something else? And so since we're having 20 equal pieces, I want to see uh, I want to take 20 equal pieces out of this right here. All right, so to get started, we have our division problem. I'm using my calculator that I on my computer. You can use this or you can use your own. So if I start out here, I'm just going to cut this out and say 10.5 because that's how long my rope is, and I want to divide it into 20 equal pieces. And this tells me how many meters long each piece is going to be, which is what I wanted to know. How long is each piece? So it's going to be 525 thousandths meters long. That's how long each piece would be. Now, keep in mind, I didn't give you the answer to number one. I just worked an example problem with you. So number two says if it is cut into 500th meter pieces, how many pieces will there be? Just like it's similar to the one before, but the only difference is now we're wanting to know how many pieces. Last time we knew we had 20 pieces. This time we do not. We just know how long each piece is. We can still do the problem very similarly because ultimately, here's what we're doing. We're taking this off, and we're taking this off, and we're taking this off because we're trying to cut it into pieces that are all 500ths of a meter. Okay? So I'm gonna still stay with my 10.5 meters long, like in my first problem. Okay, and I still want to divide, so I'll leave a little space so I can draw my division symbol in. And this time I want to see how many pieces can I get from pieces that are cut into this size. So my answer is going to represent how many pieces I have left. Not how many pieces are left, but how many equal pieces I can make. All right, let me draw my division symbol in here. Okay, there we go. All right, so if I do this with my calculator, I can divide 10.5 divided by how long each piece is. It's going to give me 210 equal pieces. So if my rope was 10.5 meters long total, the length of the whole thing before I started to cut it up, if I take off pieces that are only this much, there's going to be 210. Now you might say that's pretty big. Are you sure? Well, here's another way that you can check your answer. You can actually take your answer that you found, and we can set up a different problem, and we can say, okay, we're going to check our work here. So if we're going to check our work, we have to use our answer. How long is each piece? Each piece that we cut off is 5/100. Okay, and remember, this is not a half, this is 5/100. This is like a nickel. If we're talking about money, this would be like a nickel, just 5 cents. We would need 20 of these to make one whole or $1. So that's why I'm multiplying this. Remember. Okay. So if I have 210 equal pieces and I multiply it times how long each piece is, it should tell me how long my my rope is total before I cut it up. And if I get 10 and a half, it's correct. And look, I did. Because I got 10 and a half, that means that 210 would be correct. Because if each piece of this whole rope here, this long rope before I start cutting pieces off, since I have 210 of these size, it will equal that. Now, could you use addition here? You could add this up 210 times, but I don't want to do that. Multiplication's so much easier. It helps us get to where we need to much quicker. All right, I'm going to go on to problem B. A tortoise travels 945 thousandths of miles in 3.5 hours. If it moves at a constant speed, how many miles per hour is it traveling? Okay, so I have a sample problem here. Here's something I want to point out. This is what we want to answer. How many miles per hour? How many miles per hour are we traveling? We know that the tortoise traveled 945 thousandths of a mile in 3.5 hours. Okay, this is something that we talked about at the beginning of the year. And so I've created a sample problem that's very similar to it. This goes back to unit rate, but this part is not the unit rate. This is just the rate. Okay, this tells us how far the tortoise traveled over several hours, 3 hours. If we want how many miles per hour, that's going to be the unit rate. So when we're looking for the unit rate, remember, we're looking for how often something occurs per 1. And the unit rate here is per 1 hour. This is 3 hours. That's why it's a rate. And this one is per 1 hour. That's why it's the unit rate. So that's why we're looking for the unit rate. So if I was going to do this, here's what I got to think about. I've got to think about if I break this amount here up, because this isn't even a whole mile. It's a little bit less than 1 mile. Just like this up here, it's less than 1 mile. This is how far the tortoise traveled. This is how far the tortoise traveled in 3 hours. I need to know how fast it traveled in 1 hour. So when I set this up, it's like this: miles per hour. It's a fraction. It's just a fraction. Okay? So when we do that over here, how many miles did they go? This is how far they went. How many hours did they travel? 3. So it's basically like we're going to just divide this, because really, if you remember, a fraction is just saying divide the numerator divided by the denominator. So we're really just setting up a division problem. And I'll draw my division symbol in here. So you are going to get a decimal. You're definitely going to get a decimal here. So this is telling me per hour. Remember, this is miles. This is hours. Miles, hours. So here's what we found out. The tortoise in our example problem moved 0.25 or 25 hundredths miles per hour. Okay, you could also say a quarter mile per hour, because I need 4 quarters to make a dollar or 4 quarter miles to make one whole. So 25 plus 25 plus 25 plus 25 would be 1 mile. So that's why I'm saying a quarter hour. That would be another way to represent that. Okay. At this rate, on number 2, at this rate, how long would it take the tortoise to travel 4.6 miles? Well, we know that it's traveling this fast. We just have to figure out how, what number goes here, because really, we need to know how many hours. We already know the answer to the problem. We already know how fast it's going. We just want to know how long is it going to take us to get this far. We want to know how long it's going to take to get this far. So I'm going to leave you with this. This is like those one-step equations that we solved earlier this year as well. Okay, you could also set this up as a division problem as well. But I'm going to let you try to solve this last part since we worked through so many others. But if you can do the one-step equation, solve it this way. If you can't, turn it into a division problem. Do what's best for you. I hope this video has been helpful. If you have any comments or any questions, please make sure to contact your teacher or me, Mr. Smith, and I hope you have a great Monday. Bye.